All right, so we're moving on to energy. We've been talking about conserved quantities. We spent weeks with momentum. Momentum is a quantity that can be conserved in a closed or isolated system. Energy is another quantity that can be conserved in an isolated or closed system. Something a little tricky is that energy is even more abstract than momentum. The closest real-world analogy to energy is money. As you're all aware, there are lots of different types of money. There's cash, there's credit, there's stocks and bonds, there's Bitcoin or other cryptocurrencies. There is physical assets like your car or your house or I don't know what, your baseball card collection, lots of different kinds of money. Some of these assets are tangible that you can hold in your hand. Some of them aren't. The untangible ones, this and this, right? So, and you can also say that some of these assets require interactions. You can't have credit without having a bank or somebody else to interact with to give you credit. And some of these don't require interactions. Cash in your pocket does not require any sort of interactions. So, we are going to keep track of energy, like accountants would keep track of money, and that requires defining what you are keeping track of, as well as the interactions that are allowed. And we'll talk more about that in a sec. But the bottom line in all of this is that to keep track of energy, it is important to define the system that we're considering, including internal versus external interactions, and it's important to keep track of the types of energy we are considering. All energy can be divided into sort of two broad categories. So two broad categories, I would call these energy related to motion and energy related to configuration. So in physics, like you've learned maybe types of energy in chemistry that we're never going to touch, but you could still probably divide those into these two categories. In physics, these are the most common types of energy. So kinetic energy is an energy related to how fast an object is moving. We write this as E sub K. Thermal energy comes up too, and thermal energy is written as ETH. This is related to microscopic motion. So you know that things that are warmer have atoms or molecules or particles that are moving faster. And so that's why thermal energy is an energy of motion. So those are the two common motion types of energy in physics. Let's put this here. As far as configuration goes, so gravitational energy is related to the configuration between the Earth, right? The Earth and how high a mass is. So the higher away, like the farther away from the Earth the mass is, the more gravitational energy is stored in that interaction between the mass and the Earth. And this one we write E sub G. Spring energy. So if you stretch a spring or you squish a spring, if you deform it, it can store energy in that deformation. So that's why it's a configuration category. And really, a spring energy does require an interaction between a spring and another object, because in order to deform the spring, it has to be pressed against or pulled by something. So that's also a configuration energy. What else? Those are probably the two most common. I'm sure there are more. Okay, these configuration kinds of energies, these are things that you might see called potential energy, because they're stored in an arrangement of objects, like they require interactions, whereas these motion ones don't require multiple objects necessarily. I guess one last thing I should say is that sometimes physicists create this catch-all category for things called internal energy. And that's really just types of energy like sound or whatever that we don't want to keep track of individually, we just pile them into this one catch-all category. I will more often use thermal energy specifically, but it is what it is. So one last thing, each of these types of energy that I've mentioned here is associated with something that you can observe. So for kinetic energy, the thing you can observe that tells you it has kinetic energy is velocity. For thermal energy, the thing you can observe is temperature, although sometimes temperature changes are not so much to be easily observable, but that's really what it is. Gravitational energy, the thing you're observing is a height or a difference between the locations of two masses. Usually it's the mass and the earth, so that's why we talk about height. For spring energy, you're looking for deformation. So stretch, squish, any sort of changing of shape.